Okay, so here I was telling you, so these are the two columns and we have attached this top, or we are calling end button. So we have to provide these buttons with the center of. Now we know this distance. So this is the C distance. So how much this 116 set? So it means from the top or end button. So this is the first end button, then this is the intermediate button. So in this way we can provide, these are the intermediate buttons. So at a C distance, प्रत्येक C distance ला आपण जेवढी काही कॉलमची हाईट आहे तेवढ्या हाईटला अशा पद्धतीने आपण काय करणार, बॅटन्स प्रोव्हाइड करणार. आर यू गेटिंग? Please everyone. So this is the top, bottom means end button. All other are the intermediate button. म्हणजे 1168 म्हणजे 1.168 मीटर वरती एक प्रोव्हाइड करणार. सिमिलरली 2, 3, 4 म्हणजे 6 तर बॅटर्न्स असतील थ्रू आउट दी 8 मीटर हाईट. तर टोटल 8 मीटर असेल डिवायडेड बाय 1.168 असेल तर तुम्हाला नंबर ऑफ बॅटर्न्स मिळतील. हाऊ मच नंबर ऑफ बॅटर्न्स रिक्वायर्ड टू दिस कॉलम. आर यू गेटिंग? This is 8 meter and this is म्हणजे 1.166 because this is the C distance here. So आरामात तुम्हाला जवळपास 6 पर्यंत भेटतील. So in this way we have to means if we get the 6, त्याच्यातल्या 2 असणार आहेत त्या तुमच्या एंड बॅटर्न आणि उरलेले 4 असणार आहेत ते इंटरमिडिएट बॅटर्न. आर यू गेटिंग? ओके. So these are the end buttons. These are the intermediate pattern. Okay. Now, what is next step? This much is the, how much? 6 number is over. Means size of button we have calculated. Now number 7 is the check for stresses. Check for stresses. Okay, so here 2 types of stresses coming on this our button. So check for stresses for end button. So first we have to calculate check for stresses for end button. So now small a, shear stresses. Shear stresses. So for shear stresses the formula is VB divided by D into T. For shear stress we have to calculate, for the end button we have to calculate shear stress. So say for shear stress VB divided by D into T. So VB, how much VB is the 93 point, how much?
93.86.
93.86 divided by D, depth of section. So depth of section means depth of end button. How much depth of end button we have calculated?
334.
So 334 into thickness 8. So calculate the answer. Tell me answer. Three 4 into 8. It means how much it? Actually, this is in kilonewton. So we have to convert into Newton first. And then tell me stresses in Newton per mm square.
35.13 Newton per mm square.
10⁻³ केले का multiply?
Yes, sir.
35 point how much?
13.
35.13 Newton per mm square. Now this value should be less than Fy divided by under root of 3 gamma m naught. So how much this value? Fy is 250 divided by 3 into gamma m1 is 1.1. So how much this value? 250 divided by 3 into 1.1.
131.221.
131.21. 131.21. Correct. Newton per mm square. It means less than this. Shear stress is 35 and our this value is 131. So less than this value. So hence safe. Then small b, bending stress. So bending stresses is the formula for bending stress is 6m divided by td square. So 6 into moment. Tell me in Newton mm. Moment
13.14 into 10 raised to 6.
10 raised to 6 divided by T is 8. Now depth of end batten. So depth of end batten is again 334. How much? Bending stress in Newton per mm square.
88.34.
88.34 Newton per mm square. Now again this should be less than Fy divided by gamma m naught into 1.2. So here Fy is 250 divided by gamma m naught is 1.8 to 1.2. So how much this value?
270.73.
270.73.
272.73.
272.73 Newton per mm square. Because this is again stress. Fy is in Newton per mm square and these are the two factors. So this is again stress. So again this 88 is less than 272. It means again hence safe. The bending stress for the whatever end batten we have provided, the stress coming on the end batten, shear stress and bending stress are safe, no problem. Means whatever end batten we have provided, it will carry the this longitudinal force. Okay, so this is the check for end batten. Now calculate check for the intermediate batten. So same for intermediate batten, again we have to calculate shear stress. Shear stress is coming on this. So again VB by D into T. So VB is 93.86
86.
again. 93.86 into 10 raised to 3. Because this is in kilonewton, we have to convert it to Newton. So D. Now this depth is for intermediate batten. So how much the depth of intermediate batten?
306.
That is very important because if we are calculating the stresses for particular batten, then we have to use the dimension of that particular batten. So T here, T is the 8. So how much, tell me, the shear stress coming on the intermediate batten?
38.34.
38.34. Again it should be less than Fy divided by under root of 3 gamma m naught. So it value already, this value we have calculated 131.21 Newton per mm square. So this is less. And second we have to calculate bending stresses now. So bending stresses coming on the so for bending stress again formula is 6m divided by td square. So 6 into again moment arises, that is 13.14
14.
into 10 raised to 6 divided by t is the 8 mm into 306 square. So tell me the bending stress coming in the intermediate batten.
105.25.
105.25. Correct. Newton per mm square, and should be less than 274.25 Newton. It means correct. So hence safe. Both stresses are safe. And last step, that is step number 9. Step 9, design of connection. So here we will design the bolted connection. So I have given the procedure. So for bolted connection, so we have to calculate the number of bolts. So number of bolts is equal to, I have given the formula longitudinal, just a minute, longitudinal shear strength divided by design strength of bolt. Okay, so longitudinal shear strength we know that is the 93.98, correct. So we have to put here design strength. So it will be VDSB or VDPB, या दोन्हीतली एक असणार आहे. And so we will get the numbers. So calculate in this way number of bolts. So for that we have to calculate VDSB. So VDSB is equal to N into A and B into FUB divided by under root of 3 gamma M1. So here, as I told you, number of shear planes 1 into 0.88 in 0.78 into pi by 4 into, now we have used the 16 mm diameter. So into 4.6 grade means 400. So under root of 3 into 1.1. So that is the shear strength we got. Now we have to calculate the bearing strength. So VDPB is equal to, so 2.5 into here KB into D into T into FU divided by gamma m1. Now here maybe kb value will be changed. So calculate this values, kb value, and by using this calculate here number of ports. Are you getting? So in this way we can solve this problem by using means design of column by using the batten system. Are you getting, everyone? Okay. So if you use here 2.5, actually it will be changed. kb value here now will be changed. So okay, so we'll stop here. I have taken attendance also. Mm, so calculate the number of bolts. That's it. That's only part is here remaining.